So in this problem, we're given that cosine of theta equals the product of cosine alpha and cosine beta. We need to prove the following. Let us begin. So here, what we'll do, we're going to use a formula here. So whenever we have cosine of 2 theta, so cosine of 2 theta, then it's related to tangent of theta using the formula 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now, this entire expression is we have cosine 2 theta expressed in terms of tangent theta. If we want the other way around, that means if we want to express tangent squared theta in terms of cosine 2 theta, then using some standard algebra, we should get 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. We'll use this particular identity. Now here, let us assume that theta equals to beta over 2. So if theta equals beta over 2, then tangent squared theta, so in place of theta, we have beta over 2. So tangent squared beta over 2 will be equals to 1 minus cosine of 2 theta. So 2 theta becomes beta. And the denominator, we have 1 plus cosine of angle beta. Now, we'll use this particular relationship. So here we are given that cosine of theta, that's equals to cosine alpha multiplied to cosine beta. So let's say we isolate cosine beta from here. So cosine beta will then become equals to cosine theta over cosine alpha. So we'll substitute those values here. So we get 1 minus cosine theta over cosine alpha divided by 1 plus cosine theta over cosine beta. Right. So now we can multiply throughout with cosine alpha to get cosine of alpha minus cosine of theta divided by cosine of alpha plus cosine of theta. Right. Now what we can do, we can apply the formula. So whenever we have, let's write it down. Let's say if we have cosine of angle A minus cosine of angle B, so that's equals to 2 times sine of angle B plus A over 2 multiplied to sine of angle B minus A over 2, which means we have in the numerator 2 times sine of the angle theta minus alpha, theta plus alpha over 2 multiplied to sine theta minus alpha over 2. Now in the denominator, we have the sum of two cosine functions. So here we'll be using the formula. Let's say if we have cosine of angle A added to cosine of angle B, then this will be equals to 2 times cosine of angle A plus B over 2 multiplied to cosine of angle A minus B over 2, which means in our denominator, we have 2 times cosine of angle alpha plus theta over 2 multiplied to cosine of angle alpha minus theta over 2. Okay, so here we can factor out 2 and 2 from the numerator and the denominator. Now sine theta plus alpha over 2 divided by cosine of alpha plus theta over 2, that's going to be tangent of theta plus alpha over 2. Now we have sine theta minus alpha over 2, whereas in the denominator we have cosine of alpha minus theta over 2. But we know that cosine is an even function, meaning if we take cosine of negative theta, that is equivalent to cosine of positive theta, which means that in our case, cosine of alpha minus theta over 2, that's going to be equivalent to cosine of theta minus alpha divided by 2. So we can replace this value with cosine of theta minus alpha over 2, and the ratio sine over cosine, that's going to be the tangent function. So we have tangent of theta minus alpha over 2. So we started out with tangent squared beta over 2, and we got that this is equals to the product of tangent of theta plus alpha over 2 times theta of tangent of theta minus alpha over 2. So we have successfully proved the problem.